which substance is the oxidizing agent? So up on Moodle, you have this new thing, which is guidelines. That's just horrible. You can't read it. It's out of focus, but you can check that out. And so if I had anything better to do, I'll read it. Number 1, elements in their elemental form have an oxidation number of 0. So I've been telling you that for a while. The oxidation number on a monoatomic ion is the same as its charge. So like chloride, bromide, iodide, those are all -1. Oxide is -2. Nonmetals usually have negative oxidation numbers, although they can sometimes be positive. The oxidation of oxygen is usually -2. In both ionic and molecular compounds, peroxides are an exception, and they have -1. And peroxides are kind of easy to spot. So what they're telling you, here we have oxide. We think about hydrogen peroxide. And since I have 2 oxygens, that's going to be oxygen with a -1 charge. And we're going to see that oxygen can be our guide. And then it says the oxidation number of hydrogen is +1 when it's bonded to nonmetals and -1 when bonded to metals. So if you ever see hydrogen bonded to a metal, it's hydride and has a -1 charge. The oxidation number of fluorine is -1 in all compounds. The sum of oxidation numbers in all atoms in neutral compounds is 0. Lastly, for a polyatomic ion, the sum of the oxidation numbers must sum up to the charge on the ion. Any questions about that? Alright, it's up on Moodle, you can check it out. But we're going to make use of those concepts to figure this out. And it looks like a lot of stuff going on. Here's something where I'm going to go right away, because what do I have here? Right, so we can write what the oxidation state is. Absolutely, thank you so much. Over here, I can probably look at where sulfur is on the periodic table and do that reverse engineering thing. Due to the column where sulfur is, that's a normal oxidation state for sulfur, to be sulfide. Sulfide is -2. It's 2 columns away from a noble gas. Or it's Roman numeral number 6 up above there, and you go 6 minus 8 is -2. So we might be able to look at that and say -2 to 0. It's moving which direction on the number line? Right, so this is the oxidation occurring. So we've really done all we need to do to answer this question. Which substance is the oxidizing agent? Oxidizing agents get reduced, reducing agents get oxidized. That means this is the reducing. That makes this have to be the oxidizing.
You have to figure it out.
We could have not looked at sulfur, we could have looked at a few other things. We could have said, all right, if iron is 3 here, what is the oxidation state of iron here? Right, it has to be +2, because nitride ion, you have memorized, has -1. I got 2 of those there. So yeah, we can look at these and say +3, 2, +2, that is reduction. So this was oxidized, this gets reduced, and we can figure this out. Now we're on to something really good. Balancing redox equations by the method of half reactions in acids. A lot of these things occur in water. We see a lot of stuff going on. This method can really simplify a lot of things. We can determine oxidizing agent, reducing agent without having to go through and determine the oxidation state of all the elements. This method will tell us, they'll tell us many things, and it makes the process simple if we just follow this algorithm. So let's apply this algorithm to this example here. So it says an acidic solution. So we got hydronium and we got water, and a lot of times those species are involved. So we need to break this into 2 half reactions, and it should be fairly straightforward. Let me just start with this one. So first balance elements other than hydrogen and oxygen. Well, we don't have any hydrogen and oxygen. We just have hydrogen or iron, and then So we don't have to balance oxygen by adding water. We don't have to balance hydrogen by adding protons. We're down to balancing charge by adding electrons. So where do I need to add some electrons? Absolutely. So now it's charge balance. I have +2 on this side, +2 on that side. All right, so now we're done with that half reaction. All right, balance elements other than hydrogen and oxygen. That would be nitrogen. Nitrogen's balanced. Balance oxygen atoms by adding water. So now I have one oxygen on this side, one oxygen over there. Next up, balance hydrogen by adding protons. I got 2 hydrogens, protons. All right, now I got to charge balance this thing. -1 over here. What do I have over here? I have a +1 because I have +2 and -1. So adding more electrons to this side won't help me out. Evidently I need to add electrons to this side. It should make sense if we did this top half right. Where are these electrons going to come from? They're going to come from over here. So how many electrons do I need to add? 2. Thank you, Nick. All right, so now I have -1 over here, -2 over here, so those kind of cancel out. So now we want to sum these 2 half reactions up. And in order to do that, we need to get the same number of electrons on each side. So I need to multiply this by 2. Notice when we do that, the electrons cancel out. Sometimes other things would cancel out. So now we're going to have water plus 2 iron plus a cyanide. There, now that should be balanced in acid. Check our answer. I got 2 irons on one side, 2 on the other. Not too exciting. 2 hydrogen. I got 2 hydrogen. How many oxygens? 1 oxygen, 1 oxygen. How many carbons? 1 carbon, 1 carbon. What about charge? Oh, yeah, I'm going to do +5 on this side because I got 2 times a +3 is +6 minus 1. Water doesn't have any charge. All right, so here we come over here, and I got 2 times 2 is +4, summed with a -1, +2. That sums up to +5 as well. This one wasn't that great. We have just enough time to do one more. Maybe it was great because it worked out and wasn't too complex. But I said this really helps you to balance things that by just inspection. That's what you learned in Chem 1, is you just kind of look at your products and reactants, and there might be some things to choose first to balance that make it easier or harder. So here we go. Once again, the iron may not be that exciting. Looks like I just need to add an electron here. Balance elements other than hydrogen and oxygen. What does that mean I need to balance first down here? Absolutely. All right, then I go on, and what's the next thing I balance? Oxygens. So I put water up there and I see 7. That's gonna give me 14 hydrogens. Now the tricky part, electrons. I'm gonna just go +12 over here. What's going on here? +6. Right, +6 electrons. That now makes this a +6. And at this point we know reducing agent and we know oxidizing agent. Reducing agents supply electrons, oxidizing agents suck up electrons. Now the tricky part, I have 6 electrons here. I'll multiply this by 6, this by 6. Electrons cancel out. So now maybe we got a little more going on. 6 irons, 2 chromium, 2 chromium, oxygen, 7 oxygens, protons, 14, or hydrogen atom, charge, 18 and 6, is that 24? I got here, +14, +12, -2. Good, I get the +24. Now this is balanced in acid. All right, that's enough for today. Don't want to go over.